Hello everyone, welcome to our next generation chemistry YouTube channel. We already started IPC nomenclature series. Last class we discussed the IPC nomenclature of alkane with cycloalkenes. Today we are going to explore the IPC nomenclature of alkene and alkyne. Although these alkene and alkyne both act as a functional group. So, what is the functional group? Functional group is the group of atoms that present in the molecule and it determines the reactivity and properties of the whole compound. Let's say alkane here CH3 CH2 CH3. This is alkane because here carbon carbon single bond, and this alkane also called as paraffins. Why? Paraffins means little reactive. Reactivity is very less. Whatever the normal reagent we used in for chemical reaction, so that reactions does not affect in normal temperature and pressure. If we will not change the temperature and pressure drastically, so that's why this is less reactive. But if we convert this alkane to alkene, CH3 double bond CH CH3. So now particular this portion act as a functional group here because whole compounds here the reactivity properties depends only on this portion. That's why this is called functional group. So there are so many functional groups that we will discuss one by one. Here we discuss only hydrocarbon, that is carbon carbon single bond. We finished. Today we will discuss about alkene, means carbon carbon double bond. Alkyne, carbon carbon triple bond. Carbon carbon triple bond, that is alkyne. Here also we have to follow the same rule whatever we followed in case of alkane. Extra thing, that double bond or triple bond, that position we have to mention. All others are same. If we see the example, that will be clear for all of you. Let's say this example. CH3 CH double bond CH2. Okay. First, we have to identify the longest chain. So this will be the longest chain and number of carbon 3. So root word prop, carbon carbon double bond. So in case of alkane, we saw root word plus ane. Here root word plus ene. But one thing that you have to mention, the double bond position. So double bond position 1, 2, first carbon. So name will be prop root word, then position 1 ene. That will be the name, prop 1N. Clear? Another example, CH3 CH CH3. here C double bond CH, here CH, then CH3. So what will be the name? So longest chain will be this one. 1, 2, 3, 4, 5. Now numbering. So 1, 2, second carbon here. 1, 2, 3. Third carbon, that basically got double bond. So numbering start from right side. 1, 2. Because that functional group, that priority will be more. Double bond. So here second carbon, if it start numbering from right side, the second carbon will get double bond. But if you start from left side, 1, 2, 3, third carbon. So here less number. So 2, 3, 4. So this one act as a substituent or branching. So what will be the name? 4-methyl, 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 1, 2, 3, 4, 5. Pent. Which position? Second position. Pent 2 in. So that way we have to write the name. If we see the multiple double bond, let's say this thing, it means here carbon, carbon, carbon. Okay. So how many numbers of carbon here? 1, 2, 3, 4, 5, 6. 2 double bond. 1 and 2 double bond. So say similar process here also. So first 1, 2, second carbon. If you start from right side, that's second carbon. Here second carbon. So 1, 2. This also second carbon. If you go either left, right, both are same. Okay. So 1, both are same. So you can choose any one, either left or right. You'll get same name, numbering and same name also. 3, 4, 5, 6. Clear? Now, when the double bond more than one, that time we have to add A. It means whatever the root word, we have to add A. What is the root word here? 6, so hex. Normal root word, that basically hex. Because of here more than one double bond 2, 3, 4. So that time we have to add here A. That will be hexa. Hexa. Now the position. Which position? Second and fourth. Hexa 2, 4 di-in. Okay. So this will be the name of this compound. Now see another example. Here if I put double bond here and here another substituent group. So now what will be the name of this compound? So numbering here. So here first carbon double bond, here also first carbon double bond. But here this branching or substituent at second carbon. If we start from right side, that will be get more number. So numbering will start from left. 1, 2, 3, 4, 5, 6. So what will be the name? 2-methyl. Then because of two double bonds, So hexa 1 and 5, 1 5 diene. This will be the name. Clear? If we observe the cycloalkene, in case of cycloalkene, what will be the name for cycloalkene? Okay. Just tell me what will be the name of cycloalkane. That is cyclohexane because of 6 carbon. So in case of alkane, that will be cyclohexane. If I put here double bond, so what will be the name? That will be cyclohexene. Cyclohexene. So that will be the name, cyclohexene. So in case of cyclic compound, if only one double bond, so no need to mention the position. If more than one double bond, that time we have to mention the position of the double bond as well as triple bond. If you see the another example, for more than one double bond, this example, okay. So what will be the name? First thing, there is no branching, so that is cyclo. Because of more than one double bond, so hexa. So we have to add this A, root word with A, hexa. Now numbering. So here numbering 1, 2. When you start the numbering from double bond, you have to go through the double bond. You can't go like this. When you start from here, definitely you have to complete the double bond. 1, 2, 3, 4, 5. Which position? First and fourth. Cyclohexa 1, 4 diene. That will be the name. Clear? Done? This one? Next example. With branching. Cyclic case with branching. Okay. What will be the name of this compound? So here main thing, that is numbering. What will be the numbering in this case? Okay, I am just numbering here red. First red color. So the red color. 1, 2, 3, 4, 5, 6. Red color numbering. And another numbering, that basically black. Starting from here. 1, 2, 3, 4, 5. Clear? If we consider the red one, so what will be the name in case of red one? So second position methyl and fourth position ethyl. So that will be 4 ethyl. Because of methyl and ethyl, alphabetically we get more priority ethyl, E. So 4 ethyl, 4 ethyl, 2 methyl, 2 methyl, 4 ethyl, 2 methyl, cyclohexene. Cyclohexene. if we consider the red one, sorry, black one, so what will be the name? So 5 ethyl 5 ethyl 1 methyl 1 methyl cyclohexene, 1 methyl cyclohexene. So now the question that which one will be the correct? The correct one will be this one. This is the correct answer. And this is the wrong. Why? Because here double bond and branching started from this carbon. So that's why this numbering start from here. We can't start from here. Definitely double bond starting from here. But here double bond as well as branching. That's why this numbering, it means black color numbering, will be correct. Okay? So that way we have to practice more and more question from any books. There are so many examples that you have to practice. Without practicing, you can't be master of IPC nomenclature. Now, the next part, that is alkyne. Alkyne, that I told you, carbon-carbon triple bond. If carbon-carbon triple bond is there, that means alkyne. So what will be the thing? Here root word plus YNE. Root word plus YNE. So let's see example. So first example here, CH3C okay, CH, triple bond C, then here CH3, and here CH2, CH3. Try this one. What will be the name? So first thing that we have to identify the longest chain. So longest chain, that basically longest chain, you have to include always the triple bond. Without this triple bond, you can't consider the longest chain. So here, either the longest chain will be this direction or that direction, like this. You can't consider this direction. If you consider only that portion, it means this portion you have to consider as a substituent. So triple bond is there, so definitely that will be the part of the longest chain, principal chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So definitely this will be the longest chain. Now the numbering. So if you start from numbering 1, 2, 3, 4. So fourth carbon, that basically will get the triple bond first. But here 1, 2, second carbon. So definitely numbering, we have to start from here. 1, 2, 3, 4, 5, 6. And this will be the substituent. So first we have to write the substituent. So 4 methyl, then hex, which position? Triple bond, 2, hex, 2, 9. Clear? Now we'll see if double bond and triple bond both are simultaneously present in the same compound. So that time, what will be the process? Okay, let's see here double bond and here triple bond. So first, there is no branching, no substituent. So this will be the longest chain. First we have to count the how many numbers of carbon. 1, 2, 3, 4, 5, 6, 7, 8 carbon. That 8 carbon. Now the numbering. First carbon triple bond. Here second carbon will get double bond. So definitely functional group first carbon. So that's why numbering will start from here. 1, 2, 3, 4, 5, 6, 7, 8. So what will be the name? So name oct, then in and ion, two double, in and ion. So alphabetically which one is more preferable? E. So which position? 6th position. Oct, 6 in, then which position? First 1 ion. So that will be the name. Clear? Oct, 6 in 1 ion. I told you the number and what in between, that will be the hyphen. Number, that will be the comma. So here that you have to maintain. Now another example. If we see, okay, what will be the name? First thing that you have to identify the longest chain, that is principal chain. Principal chain. So if we start from here, 1, 2, 3, 4, 5, 6, 7. So is there any other option to get principal chain? No, there is no other option. Why? Because double bond, triple bond, that will be the part of the principal chain. We can't ignore because both are functional group. So this will be the principal chain. Clear? Now the numbering. What will be the numbering? So definitely numbering will start from here because first carbon got double bond. Here first 1, 2, 3. Third carbon will get the thing. So definitely this will be the first, second, third, fourth, fifth, sixth, seventh. Now this will be the whole thing will be substituent or branching. So how many numbers of carbon? This one. 1, 2, 3, 4 carbon. 4 carbon. So which position? Third position. So 3 butyl because of 4 carbon. So that substitution will be butyl. Then hept 1 in and 4 I. Clear? Is there any difficulties? No. It's very simple. That you have to follow the rules only. And you have to practice more and more. If we see another scenario, let's say here triple bond, here double bond. Now the numbering. If we start from right side, the first carbon, that is triple bond. If we start from left side, that first carbon, that is double bond. So when that basically both are same, if we start either left or right, both basically first carbon, here double bond, triple bond. So which one will be more priority? So definitely double bond will be greater priority as compared to triple bond. This is the order of functionality. When we learn one by one all functional group, after that we'll see the list of priority, that functional group priority. So if you check the priority list, double bond is greater priority as compared to triple bond. That's why here numbering will start from here. Whatever example we saw earlier, that basically either double bond or triple bond got lowest number, but not similarly here. If you start from right, that first carbon triple bond. If you start from left, first carbon double bond. That kind of scenario we didn't observe. So now in this scenario, double bond will get more priority. So first, second, third, fourth, fifth, sixth, seventh, eighth. So what will be the name? So name that basically oct. There is no branching or substituent group. Oct, which position in? 1 in, then 7 I. That will be the name. I think you got the overall concept about alkene and alkyne. From the next class, we'll start the functional group, all other functional group, one by one. So now you have to practice only. From any book, you can find so many questions that you have to practice. I am telling again you, without practicing, you can't do the nomenclature. Okay, thank you.